Let's go. Okay, we're going to do integration by substitution again. So we're going to find antiderivatives. You guys now have a foundation after our other day in, when we were here, we practiced a few problems together. You have some problems on your worksheet. You know that in this situation, I identify what u is. Who can tell me what u is going to be here? X squared plus 2. Good. Du is the derivative of this. What is the derivative of this? 2x. Notice what's left here. I don't have a 2x, do I? I could get rid of the 2, right? Let's divide by a half, or by 2. I get 1/2 du is equal to x dx. What's the problem? X cubed. I need another x squared, don't I? I'm going to rewrite the integral to look like this. Integral of x squared times x squared plus 5, 2, sorry about that, to the 5th dx. All right, I'm going to cross some things off. 1/2 du. What do I get to cross off with 1/2 du? X dx. Good? What do I get to put in place of that? U to the 5th. I got to get rid of everything. The x squared can't stay. If only I knew what x squared was equal to. If only I knew what x squared was equal to. U minus 2. See that tricky? Now here's where people get confused. They're like, well, I don't know what I'm doing when. We haven't taken an antiderivative yet, have we? In order to do this antiderivative, I should really distribute through. So I have 1/2 times the integral of u to the 6th minus 2u to the 5th du. Now I can find the antiderivative. 1/2 times, what's the antiderivative of u to the 6th? Yep, u to the 7th over 7. Minus what? 2u to the 6th over 6, right? Or u to the 6 over 3. So at this point is when I like to plug in back what u is and multiply by my 1/2. So u is, what did we say, x squared plus 2? So I've got x squared plus 2 raised to the 7th over 14 minus x squared plus 2 to the 6th over 6 plus a constant. We're done. Now, go ahead. What's crazy is if you take the derivative of this, you come up with that. That's not easy to see, is it? So substitution in this situation, you don't have to love it. You need to be impressed that the antiderivative of that is this, and we were able to find it so easily, and they don't really look the same at all. That's pretty good. You're ready. You're doing well. Here we go. What's going to be u for the second problem? X cubed minus 4. So what is du? 3x squared dx. You tell me what to do now. divide by 3, multiply by 4. Okay, good. So we got 4/3 du is equal to 4x squared dx. What do you want to do now? Rewrite it. So I'll rewrite the integral to be 4 what? 4x squared times x cubed times x cubed minus 4 to the 3rd power dx. Good. Time to substitute. What do you want to put in for what? So you went over here right away. You said u plus 4 is equal to x cubed. So you want to get rid of this guy, and you want to put in u plus 4. That's fine. I still got stuff to get rid of. $4x squared in the dx, what did you put in its place then? 4/3 in du. Good. What's my last? Yeah, u cubed. That thing is u to the 3rd. Not too bad, huh? Look at that. Took a problem that looked like it was super challenging, and now we're making it easy. Why? Because you are super smart. I don't think you understand how smart you are. Like if you looked at the percentile people across America, you would be like top 10%. Good for you. What's that? This guy said, you feel like that says that our society as a whole isn't as quite as intelligent as we would hope. We test everybody. We educate everybody. Here we go. Let's take the antiderivative. I got 4/3 times u to the 5th over 5 plus what? U to the 4th. At this point, I'm going to plug u back in. So I've got 4 times x cubed minus 4 over 15 plus 4 times x cubed minus 4 to the 4th over 3. What did I do? Three times 5, 15. Oh, sorry. Thank you. Don't be so nice next time. Just like scream at me. You're very humble. This one can sneak up on you. Most people will not get this right. What do you want you to be? What is du? What's the derivative of cosecant? Negative cosecant cotangent. Don't worry about the 4th power. We'll deal with that later. Everybody okay with the derivative cosecant is negative cosecant cotangent? Okay. Yep. That's why this is good review, because you're having to review derivatives and antiderivatives, right? It's a very important unit. I'm going to get rid of the negative. Negative du is equal to cosecant of x cotangent of x dx. Now what's my problem? I have an extra cosecant. Could I rewrite this so it shows an extra cosecant? How? Good. So there are 4 cosecants being multiplied. I'm going to write 3 of them being multiplied. I'm going to put the other one here. Same expression, right? Now that I did that, now it matches up perfectly, doesn't it? I substitute negative du, and what do I get to get rid of? I get to, so that thing takes that thing away, right? Great. What remains? U to the third. What's the antiderivative of u to the third? Yeah. So u to the fourth, or cosecant to the fourth over 4 plus my constant. Looks pretty challenging, right? But if we think to separate it, that really helps. Hacker's got a headache. He's like, yes, I can't take any more of this. Just about done. This is easier than the other stuff? Mark those words. We'll write them down. What do I do when I get that face? Oh, okay. We give up. All right. Okay. All right. Oh, boy, folks. This one. It's a doozy. Now, I've taken off a lot of the doozy problems, but I don't want to take this one off. And here's why. Let's do it. What do you want u to be? Yep. What is du? Negative dx, right? That's all I got. Oh boy. There's a 3x squared up here, isn't there? Maybe I could at least get rid of the negative and add a 3 in. Do you want to do that? So I'll multiply by negative 3. So negative 3 du is equal to 3 dx. I got to get the x squared. There's not even an x squared up here. These are fun. Okay, here we go. Time to substitute. I got a negative 3 integral du. So what does that get rid of in my original problem? No. The 3 dx. Alex, what should I put in place of the x squared? What should I put in place of the 4th root of 3 minus x? U to the 1/4. See, sometimes people say u to the 1/4, and I say u to the 1/4. But then they say, no, u to the 1/4. I say, no, u to the 1/4. It's a calculus joke, Shelley. Oh, I was so popular you wouldn't even know. Okay, here we go. So negative 3 integral. So I'm going to get rid of this guy on the bottom. I'm going to write this as 9u to the negative 1/4 minus, and then if I have u to the 4/4 over u to the 1/4, that will give me u to the 3/4. And then u to the 8/4 over u to the 1/4. Good. All right, so we're going to take that antiderivative. Awesome. -3 times, it's going to be 9u to the, you're taking the derivative, positive 3/4 divided by 3/4. Minus 6u to the 7/4 divided by plus u to the divided by 11/4. Let's just polish it off. We're almost done. 3 minus x is my u. So I will, if I'm dividing by 3/4, I will multiply by 4 and divide by 3, right? So those 3's will cancel. So I get a -36 on top. And it's 3 minus x to the 3/4. Okay, the next sign is going to be positive. I'm going to multiply by 4 and divide by 7, right? So multiply by 4 gives me 24 times 3 is 72 over 7, plus 72 times 3 minus x to the 7/4 over 7. Next one's going to be a minus. Multiply by 4, divide by 11. So -12 over 11. That's going to be 3 minus x to the 11/4. You know what's awesome about that? If you take the derivative of that, what do you get? This little thing right there, right? That's remarkable. Somehow, when you take the derivative of that, you get that. Like, it just blows your mind. Like, where does everything go? It must be Christmas. Everything just, like, cancels, and it's good. And that's that. Fun times.